Hello, good evening, everyone. I hope you all are fine. And today we are going to study the numerical of electricity. So, everybody pay very good attention here. How to solve the numerical of electricity. After the class, you everybody must be able to do all types of numerical related to the electricity at your level. Okay. There are different types of numerical related to the electricity. We have to know different types of formula related to the electricity. Last time in my last video, we have studied some formula like V is equal to IR. Okay, that is voltage or simply potential difference is equal to current into resistance. Similarly, we have also studied if the resistor are connected in a series combination, then res equivalent resistance is equal to R1 plus R2 plus R3. How many resistors are added in a series? All the resistors will be added to find out the equivalent resistance. Similarly, if these resistors are combined in a parallel, then the equivalent resistance Re can be calculated like this: 1 by R1 plus 1 by R2 plus 1 by R3. Also, uh, one formula is there: electric power is equal to current into voltage, that is potential difference. Electric power is equal to current into potential difference. We everybody must know that what is this symbol. V means potential difference or voltage, I means current, R means resistance. Here Re represents equivalent resistance, and these are the resistors that can be bulb, fan or something. Okay, and this P is electric power, I means that is electric current, and V means that is potential difference or voltage, we can say. Another formula is there. We know that power is equal to work by time, or also we can write the electric power is equal to energy converted per unit time. We can also write like this: energy by time. And here to find out the energy, we can change this formula like this: energy is equal to power into time, and this is the total electric power. This is the energy consumed, electrical energy consumed to convert electrical energy into other form of energy, and this is the time for which the instrument has run. Suppose 60-watt bulb is running for 2 hours, then this power is 60, and a time that is 2 hour, that can be kept in uh, for this numerical we have to keep the time in hour. So if 60-watt bulb is running for 2 hour, then simply 60 into 2, then we can find the electrical energy consumed in 2 hours. Okay, if there are different number of bulb, suppose there are 5 bulb of 60 watt, then this power this total power can also be written like this: number of bulb into power of each instrument into, and this time will be here. In this way also you can find the electrical energy consumed by using this formula. N represents number, P represents power of each instrument, and T represents for how many hours this is running. Suppose this is running for 6 hours, then 6 will be here. I hope you are understanding this. So our one formula is this to calculate the electrical energy consumed, and through this formula we can find out the electrical cost of our domestic appliances that we are using for 1 month or for 1 day by using this formula. How much electrical cost it is coming for 1 month we can easily calculate by using this formula. Okay, how we will use, just after some minutes we are going to use this formula. But here when we are using this formula we have to be very careful. This n is the number and this power is not the total power, it is the power of each instrument. Okay, and while calculating this numerical we have to keep this power in kilowatt. Normally the power of any instrument is written watt, that is the SI unit, but for doing this special numerical we have to keep the power in kilowatt. Why we are keeping, let us understand. And this time should be in hour. Power will be power will be in kilowatt and time should be in hour. Why? Because if we are putting here kilowatt and this is hour and this is the number do not have any unit, then this has kilowatt and this has hour, the energy value will come in kilowatt hour. The value of energy that will calculate, that will come in kilowatt hour. And when it comes in kilowatt hour, we know that 1 kilowatt hour is equal to 1 unit. This 1 unit that is increasing in our meter box, that represents 1 kilowatt hour. How many kilowatt of hour, how many kilowatt hour energy will be used here? It means that much unit will increase in our meter box of our domestic uh, appliances. We have a meter box in our home. How many kilowatt hour of energy is using there? According to that, that many units will increase in the meter box. So we have to keep here power in kilowatt and time in hour. I hope you are understanding this. When we will use this formula we will better know there. Okay. Let us see the numericals related to this. Some numericals we are going to do related to this formula. Let us see first type of numerical. Like suppose in any question, I am taking some example I have here. In any question given there, the value of current we can represent by I. The value of current is 200 milliampere. Okay, and the value of voltage, that is potential difference, is given here, suppose 20 volt. Okay, and here we have to find the value of resistance is equal to what. Then when we see this we can use this formula, V is equal to IR, but the value of I should be in ampere. When we are using this formula, this is the potential difference, its formula its value should be in volt. This is the current value should be in ampere, but here V is given here volt. We do not have to change this, but it is current value is given in milliampere. So first we need to convert that milliampere into ampere. Then we can convert like this: 200 divided by 1000, then it comes in ampere. When we divide a milliampere by 1000, then it changes into the ampere. I hope you are understanding this. Okay. Now this value comes, suppose 2 to cancel and 0.2 ampere. Now we can use this value here at place of I. V value is given here 20 volt, so 20 is equal to 0.2 ampere into R. Now this we can easily find out. 20 divided by 0.2 is equal to R, and if you calculate it, you have a calculator, calculate it, how much value it will come, that much. Suppose it is coming suppose it is coming 100, then 100 ohm is equal to the value of R. The unit of resistance is ohm in ohm, so we have to write here ohm, so this will be our answer. Understood? Next type of numerical, let us go to understand. Next type of numerical is like this. Suppose 1 kilowatt heater is there, and another instrument, suppose 100 watt tungsten bulb, filament bulb is there. 100 watt tungsten bulb or filament bulb, we can say tungsten bulb is there. Okay, and these both are supplied with 220 volt current, 220 volt potential difference they are supplied with, and it is asked uh, which has more resistance. Okay, then let us see which has more resistance. This is 1 kilowatt heater, that is given, this is 1 kilowatt heater, it means it is 1000 watt. We can say, we can change the kilowatt into normal watt. Similarly, here power is given 100 watt, here V value is given 220 volt, and this V is also same. It is said that both instruments are supplied with 220 volt potential difference, so both value, V value will be 220 volt. Then it is saying which has more resistance, then we have to find here R is equal to what, and here also R is equal to what. Let us see first. P and V is given, we have to find the value of R. Then which formula we have to use? We do not have direct formula relating the P, V and R, is there? No. Then let us see another indirect formula. We have studied P is equal to I into V. Okay, and from Ohm's law, V is equal to IR from Ohm's law. Then value of this I will be V by R. At the place of this I, we can write V by R. So P is equal to V by R into V. Okay. P is given here 1000, V is given here 220, again V up here 220 divided by R. Okay, and this R value will be 220 into 220 divided by 1000. Now you calculate with your calculator how much it is coming. Okay, we can find out this resistance over here, something it will come this much ohm, something is this value will come. Okay, now we are calculating the resistance for this. When we are calculating the resistance for this, let us see, same formula we are going to use. P is equal to V divided by R into V. Here P is how much? 100 watt. So 100 is equal to V is 220 into 220 divided by R. In similar way, we find out the value of R 220 into 220 divided by 100. This is cancelling and something value will come here. R is equal to something ohm. And here, after finding this value with a calculator and this value with a calculator, you can compare which has more resistance. Here 22 into 22 divided by 10 it is. Here 22 into 22 only. So when you observe this, when you will calculate, you will find that this value is more. Okay, this resistance is more. Even it has less power, this instrument has very high resistance. Okay, you can find out by using the calculator. You can compare whose resistance is more. Okay, you understood how to solve such type of numerical. If it is said this instrument or this instrument which has more resistance, first you use the formula and calculate how much it is coming. According to that you interpret your answer. Now another type of numerical we are going to understand. uh, uh, we are now in this third part. We are going to understand the numerical related to domestic electric cost in our house. Suppose it is said at any place of any hostel or any school or somewhere. Suppose there are 200 bulbs, okay, of 60 watt, 60 of 60 watt each, run for 6 hour daily. 6 hour daily, that bulb, 200 bulbs of 60 watt is running 6 hour daily. Okay, another condition is given here. 50 fans of 40 watt each are running uh, 12 hours, sorry, 40 watt, not 75 watt, 75 watt each, running 12 hour daily. Now we have to calculate daily this instrument is running, this much instrument is running. Then we have to calculate after 1 month what will be the electricity cost if 1 unit is equal to RS 7.5. It is the question. Right, this much instrument is running this much hour, and after 1 month, if 1 unit is equal to 7.5, then what will be the total electric cost for 1 month? We have to calculate. I hope you have understood the question. Let us see how to solve this. Bulb is there, then first we have to calculate energy consumed by bulb. Formula is N, P and T. N is the number, 200 into power of each instrument, here 60 watt. And one more thing we need to notice here is given in watt. We have to convert, we require the answer in kilowatt hour. So we have to convert this watt into kilowatt by dividing by 1000. Similarly, time is given in hour. That is okay, we do not have to change it. 6. So that answer will come in kilowatt hour. Okay, we can calculate this. It is coming 72 kilowatt hour. You can use the calculator. Next, energy used by fan, same formula, NPT. Number of fan is 50. Power of each instrument is 75. And divide, we have to do divide because we need the answer in kilowatt. It is given in watt. So divide by 1000, it becomes kilowatt. And daily it is used 12 hours. Okay. Then we can calculate this. If you have calculator, please calculate it. How much it will come? Suppose uh, I think it is coming 45 kilowatt hour. You do by calculator. Okay. Now total energy used is equal to energy by bulb plus energy used by fan is equal to 72 plus 45 kilowatt hour in one day. Okay, in one day energy is equal to bulb and fan, they are using this much kilowatt hour of energy in one day. Okay, 117 kilowatt hour energy is used in one day. Then in 30 days, how much energy is used? The 30 into 117 kilowatt hour. Okay, you please calculate by calculator. Something value will come here. Something value kilowatt hour. Okay, then we know that 1 kilowatt hour, it means 1 unit. At the place of kilowatt hour we can say 1 unit there simply. Otherwise please, it is 117 kilowatt hour in one day it is used. So we can also say 117 unit in one day it is being used. Here you can directly write unit because 1 kilowatt hour means 1 unit. So in 30 days how many units is used? In one day this much unit, then 30 days that much into 30, you calculate this, and that much unit is used in 30 days. Okay, then here value is given, 1 unit is equal to 7.5 rupees. Then this much unit is equal to how much? This value into 7.5. Whatever the value will come, that is our total electric cost for 1 month. Okay, I hope you understood this. Still, if you have problem, you will comment. I'll make other video for you. This is the uh, numerical related to the domestic electric cost. 1 minute. Okay, now, okay, hello, I came again. Now the numerical can be asked related to the register. There are different combination in register. Suppose a question can be asked to us. Suppose two resistor of 2 ohm each. Suppose two resistors. Suppose R1 value is 2 ohm, R2 value is 2 ohm. Current value is given. Suppose 5 ampere, and we have to find here equivalent resistance is equal to what, and V value is equal to what. And if these resistors are in question, it is given resistors are combined in a series combination. If the resistors are combined in a series combination, this data is given and we have to find equivalent resistance and potential difference. Okay, let us see how it is done. Here R1 R2 given and it is series combination saying, then for series combination we have studied the formula for equivalent resistance is simply whatever the resistors are there, we have to add the value of all resistors, that will give the value of equivalent resistance. Okay, simply it will be 2 plus 2, it comes 4 ohm. Here value of I is given 5 ampere, we have to find the value of V. Then V is equal to IR, and this R means equivalent resistance. V is given, sorry, V we have to find out. I is given here 5 ampere, 5 into RE is how much? 4. So 20, it is potential difference. The unit of potential difference is V. In this way we can do this.